All right, going into rational expressions and rational equations. So factoring is going to be a big part of this. So make sure you're comfortable with your factoring strategies that we discussed previously. All right, example 1, find all values for which the rational expression is undefined. So a rational expression or any expression is undefined. Undefined is caused by division by 0. So it is undefined for any x value that causes the denominator, that's terrible, let's try writing that again, denominator equals 0. So it is undefined for all values of the variable that cause the denominator to equal 0. So looking at this first one, x plus 6 divided by x minus 5 times 2x plus 1. So we're only worried about the undefined portion, which means that is where anything out of the denominator equals 0. So I'm going to take my entire denominator and set it equal to 0. This is in factored form. So what that means is when something's in factored form, if we're trying to solve and it's set equal to 0, that means one or both factors could be 0. So we would just take each individual factor and set them equal to 0 on their own. So I would take the x minus 5 and set it equal to 0, and the 2x plus 1 and set it equal to 0. And then we're going to solve each independently for x. So for this first one, I'm going to add 5 to both sides. So we get x equals 5. For the other one, I'm going to subtract 1 from both sides. So we have 2x equals negative 1. Then we're going to divide off the 2 to get the x by itself. So we have x equals negative 1/2. So remember, these are not solutions. This is an expression. Expression does not have solutions. This is where the expression is undefined. It is undefined for x equals negative 1/2, comma 5. Right, second one. X plus 6 over x squared plus 3x minus 18. So again, we're not worried about simplifying, just where the expression is undefined. So that means only looking at the denominator. So I'm going to pull my denominator, set it equal to 0. So difference here is this one is not factored, so we have to go through the factoring on our own. So I'm looking at this. My leading coefficient in front of the x squared is 1, which means I can go straight to my double bubble. X squared always splits x and x, so we are looking for two numbers that multiply to give us negative 18, and those same two numbers have to get us to positive 3. So 18 and 3 is what we're working with, so that would be a 6 times 3 is 18. Now to figure the sign out, our goal is to get to a positive 3, which means I need to make the bigger one positive and the smaller one negative. So then we pick it up where we did the last one. Each individual factor gets set equal to 0. I'm going to move my 6. So x is negative 6. And then we're going to move the 3. So x equals 3. So we are undefined for x equals negative 6 and 3. Now just be careful with this one. Do notice one of these factors from our denominator was in the numerator as well. Always do undefined before you simplify your expressions. All right. Simplifying rational expressions, we're going to do both multiplication and division, and then we will do addition and subtraction. So simplifying each rational expression, leave your answer in factored form. All right, so first one here, we've got 2x squared over 5 times 3 divided by 4x. So essentially we're going top times top, bottom times bottom. So these are all individual terms, so we can just multiply the numerical values together. So 2 times 3, that's a highlighter, is 6. And then we just stick the x squared on there. Over bottom times bottom, 5 times 4 is 20x. Then we need to look at getting this thing reduced. So we're going to reduce both the numerical values and the variable values. So we're looking at 6 and 20. 6 and 20 are both divisible by 2, so we're going to divide out that common factor of 2. So that's going to leave us with a 3. And then on the denominator, if we take out a 2, we're left with a 10. As far as the x's or variables go, for every 1 power on the top, you are allowed to remove 1 power on the bottom. So I have 2 powers of x on the top. I have 1 power of x on the bottom, so that means I can take out 1 power of x on the top, and I can take out 1 power of x on the bottom. So there is going to be a single x remaining on top and no x's remaining on bottom because there was only 1. So this would be our simplified expression. All right, B, 6a minus 30 divided by 6. So first thing, I don't see anything I can divide out. Algebraic no-nos. You cannot divide out terms. You can only divide out factors. So do not go and take the 6's out this way. So when you divide out, it has to be something that's being multiplied. So instead, we need to think factoring. So I'm looking at that numerator. That numerator, the term 6a and the term 30, both have a 6 in common. So we're going to factor out the common factor 6. That is going to leave us with a minus 5. Now, because this 6 on the numerator is attached with multiplication, it is now considered a factor, and we can divide the 6's out now because they are both factors, which leaves us with a minus 5 for our expression. All right, third one. All right, now going into full multiplying. So here, what we do not want to do is similar to the first one where we just multiplied things out. We do not want to try to do that because the last one was just single numerical values. That's easy to multiply and then reduce from there. Here, these are polynomials, so what you want to think is get everything as factored as much as you can and then divide out common factors. So we're going to factor everything and then divide the common factors out. So first numerator is x squared minus 9. From our factoring, that is our difference of squares. So that is going to factor to x minus 3 times x plus 3. Its denominator, x plus 1, there's no common factor. It's not a power of x, so it is already factored. So I'm going to put it in a set of parentheses to show that it's factored. Second numerator is also a difference of squares. It factors to x plus 1 times x minus 1. And the denominator, x plus 3, is already factored, so we're going to give it its own bubble as well. For every factor that is identical on the top, you can remove one factor that is identical on the bottom. It doesn't matter if it goes diagonal, because remember, fraction multiplication, you multiply the tops together and the bottoms together. So it's essentially like one big giant fraction. So I look at this and I have an x plus 3 on the top. I also have an x plus 3 on the bottom, so I'm allowed to divide both of those out. I have an x plus 1 on the top. I also have an x plus 1 on the bottom. Those can be divided out as well. Nothing else is identical on the top and bottom, so that leaves us with the x minus 3 times x minus 1. Everything on the bottom divided out, so we only have the numerator left. Right? Going into division. So for division, very, very similar to multiplication with one extra step. I call it the keep, change, flip. Division by a fraction is the same as multiplication by the reciprocal. All right, simplify each expression. All right, so first thing we want to do here is we need to make sure that we catch that this is a division symbol between them. I want to immediately change it to multiplication, so we're going to keep it. The x first fraction stays. We're going to change it. Division becomes multiplication, and then we're going to flip it. So the numerator and denominator are going to change places, trade places. So with the 2x plus 1 comes up, and the x squared minus 6x minus 27 goes down. Keep it, change it, flip it. Then we proceed like we did with the multiplication problem because that's what it has become. So factor everything and divide out what you can. All right, first numerator, x plus 3 is as factored as it's going to get. First denominator, that is a difference of squares because the 4 is 2 squared. So that becomes 2x plus 1 times 2x minus 1. My second fraction, numerator, is 2x plus 1. There's nothing in common, so it's as simplified as we can go, so we're going to bubble it. X squared minus 6x minus 27. Leading coefficient's a 1, so I can go to my double bubble. I know it starts x and x, has to multiply to negative 27 and add to 6. So multiply to 27, that's 9 and 3. To make it negative 6, the bigger one needs to be negative and the smaller one needs to be positive. All right, looking for identical factors. I have the identical factor x plus 3 on the top and on the bottom, so they are gone. Identical factor 2x plus 1 on the top, 2x plus 1 on the bottom. Both of those are gone. Nothing else matches. So what's left, make sure you're very careful with this one. Nothing is left on the top, but you can't leave nothing if you have to write a denominator. We use a 1 to hold the place of the numerator. So we got a 1 on top, and then a 2x minus 1 times x minus 9 on the bottom. So anytime the numerator disappears, we use a 1 to hold its place. When the denominator disappears, we don't need the division by 1. It's implied. All right, next one. All right, it's division, so immediately keep it, change it, flip it. All right, so I've got my negative 2x minus 10 over x squared plus 10x plus 21. Change to multiplication. The x plus 7 comes up and the x plus 5 goes down. Factor everything. All right, first one, negative 2x minus 10. They have a 2 in common and a negative. Remember, never leave the front term negative. So we're going to take out a negative 2. That's going to leave us with an x and then a plus 5. For the second, or for the first denominator, leading coefficient is 1, so that's a straight double bubble. I know it's x and x. Multiply to 21, add to 10. So that's 7 and 3, and they're both positive, so both pluses in the factoring. X plus 7, there's nothing we can do, so we're going to bubble it. And x plus 5 already factored as well. All right, looking to divide out. X plus 5 matches top and bottom, gone. X plus 7 matches top and bottom, gone. So if we look at what's left, I have a negative 2 on the top, that's the wrong color, over x plus 3. All right, here, it's just a different way to write a division bar. Remember, a division bar could be used in place of a division symbol. It still means the same thing. We are still going to apply the keep, change, flip. So we are keeping the first fraction, which is the one in the big numerator. So the a squared minus 16 over 2a plus 6 stays. Changing that main division bar here is what we are changing to multiplication. And then we flip the second fraction. So the a plus 3 is going up and the a minus 4 is going down. All right, factor everything. All right, first numerator, difference of squares. A plus 4, a minus 4. First denominator, they have a 2 in common. So we take the 2 out. That leaves us with a plus 3. Second fraction, numerator is factored, so it's going to go in a bubble. Denominator is also factored. And then we're playing the divide out game. X plus 3 drops, or a plus 3 drops a plus 3. A minus 4 drops a minus 4. Make sure you don't accidentally cross off the plus 4. The signs are different. So we have an a plus 4 left over 2. Scoop change that to where it's underneath. There we go. That looks better. All right, adding and subtracting. So we've done the multiplication, division. Now we're going to do the addition, subtraction. So multiplication, division, we change it all to multiplication. Just divide out everything identical on top with one that's identical on the bottom. Addition, subtraction is not that simple because you have to have a common denominator. So you can read through that example there if you want to. All right. First thing we're going to do, find the least common multiple of the given terms. The reason we're going to find the least common multiple is because that is what we're going to use to make sure to get our denominators to match so that we can add or subtract. So factoring, again, very, very important. So to get the least common multiple, we need to get everything into its most factored form. So x squared minus 9 is a difference of squares. It is x plus 3 times x minus 3. The second one, x plus 3, is factored, so I'm going to put it in its own bubble. And then the third one, 2x plus 6, has a 2 in common. We're going to take it out, and we're left with x plus 3. All right, the least common multiple, or LCM, is each unique factor used the fewest number of times as possible to make them match. So basically, we're going to go left to right, writing down each factor the most times it appears. So we're looking at powers. So I'm going left to right. So the first thing I run into is the factor x plus 3. Well, I haven't written anything yet, so that means I have to write down an x plus 3. I move to the next factor. X minus 3 is different, so I have to include it as well. I move to the next one. X plus 3 is a repeat of one we've already listed, so we don't need to list it a second time. The only way it overrides it is if the power is bigger. So let's say, for example, that this x plus 3 was a power of 2. That means I can't keep 1. It's not enough. I would have to change it to the bigger exponent. But since they're the same, we're just going to skip over it. I go to the next one. I run into a 2. We don't have a 2 yet, so we're going to use it. I like to list the single numbers at the front. So I'm going to put the 2 on the very front. And then once again, this x plus 3 back here is also a repeat of the first one because it's the exact same power of it. So our least common multiple would be 2 times x plus 3 times x minus 3. So second one. So we got 2 here. So first thing we got to do is get everything completely factored. So I'm looking at this first one here, and a 4 and a 2. So they do have a 2 in common. That leaves me with a 2. Whoops. They also have x's. They have 2x squareds. That's going to leave us with a 2, an x squared. And then we took the whole 2 and the x squared out, so we leave that minus 1 to hold its spot. For the second one, never leave the front negative. So I know I'm taking out a negative 1. And then they have an x in common. That leaves us with, it changes the sign, x, and then it's going to change the sign, so minus 2. All right, when you're doing least common multiples, I would just go left to right. So our LCM here, left to right, first thing I run into is a 2. So notice we're not looking at the 2x squared together because factors are separated by multiplication, and there is multiplication in between the 2 and the x squared, so we look at them separately. So first thing we hit is a 2. Then I run into the x squared. Well, I don't have any powers of x, so I'm going to write it down. I keep moving. Next thing I run into is 2x squared minus 1. I do not have anything labeled 2x squared minus 1 because it's a whole group, so it is considered different from what we've already listed. Then we keep going across. I'm running out of colors. Let's go dark blue. Be very, very careful with negatives. The negative and x are treated separately, just like the 2 and the x squared were at the beginning. So if it helps, slide a 1 in between. That is different. So we haven't used a negative, so that means we need the negative as a common factor. Then we run into a singular x. So this singular x right here matches the first one. However, the exponent is smaller, so we ignore it. If the exponent's smaller than what you've already used, do not relist it. It only changes if it's bigger. So if this was a 3, we would go to the 2 and we would change it to a power of 3. So we're skipping the x. And then the next one we run into, what have I not used yet? Oh, I need another color. Orange. X minus 2. So this is kind of a very weird LCM. All right, simplifying. All right, so these are being subtracted. So in order to add or subtract rational expressions, the denominators must be identical. So if we look at this problem here, first denominator is x minus 4. Second denominator is x minus 4. They are already identical. So what that means is I can go ahead and make this one big fraction. Denominators do not change. So the denominator is going to stay x minus 4. So what we're doing is we're taking numerator 1. Notice I'm putting it in a group. Minus numerator 2. So then we go through and simplify the numerator. The denominator is as simplified as it can get, so we're working on the top. The 3x plus 1, the parentheses aren't really necessary in this case, but sometimes they will be, so I do think it helps to go ahead and use them. However, in the back, they are, because that negative, that subtraction, does need to get distributed to both of those. So that's going to give us a minus x and a minus 9, extra long division bar, x minus 4. And then we combine like terms. So the 3x and the negative x can go together. 3 plus negative 1 is a 2x. And then the 1 and the negative 9, 1 minus 9, negative 8. Once you condense it as much as possible, you need to double check for factoring. Sometimes you'll be able to go further, sometimes you'll be done here. So if I look at this problem, I'm focusing on that numerator. They both have a 2 in common, so we're going to factor that 2 out, which is going to leave us with x minus 4. And then at this point, notice we have an identical factor on the top and bottom. So the x minus 4 divides out with the one on the top and the one on the bottom, which leaves us with just the 2. It's not very often that they will factor and reduce, but you do need to be able to catch it when it does. All right, so if we look at this one, I have denominator x plus 4, and then I have different denominator x minus 5. All right, so these two denominators, they are completely factored. So what I'm going to do is I'm going to put each in its own little bubble to show that they're factored. So what we're going to do here is take the idea of the least common multiple, and what we tend to call it instead of LCM, we call it the LCD, because we're referencing the common part from the denominator. So your LCD is the same idea as the LCM. It's the same thing, it's just focused on the denominator rather than just scattered terms. So every factor that's different from a denominator needs to go into the LCD. So first one I run into is x plus 4. Second one from the denominator is x minus 5, which is different. So we're going to use both of these. So the goal is we have to get both of these in our denominator. So let me recopy that problem. X minus 2 over x plus 4 plus x plus 3 over x minus 5. So I need to multiply each fraction. Remember, it's an expression, so we have to multiply by a form of 1. So we're going to multiply each individual fraction by the form of 1 using the missing factor or factors from the LCD. So if I look at my first fraction, the only thing in the denominator is the x plus 4. I am missing the x minus 5. So I am going to use the x minus 5 as my form of 1 because the denominators have to contain everything in the LCD. So the x minus 5 goes in for this one. For the second one, if I look at this, I have the x minus 5, but I am missing the x plus 4. So I'm going to use the x plus 4 as my form of 1. All right, so I'm going to rewrite this because I've got colors all over the place. So I'm going to turn both of these into their own fractions. Each factor gets its own bubble. So the x minus 5 gets its own bubble. The x minus 2 gets its own bubble. So each numerator goes in a set of parentheses. Denominator, same thing. The x minus 5 and the x plus 4. I have my plus sign in between. And then I'm going to do the same thing with this other fraction. The x plus 3 in a bubble and the x plus 4. And then to the denominator, x minus 5, x plus 4. All right, so then we want to look at our denominators and make sure they match. Remember, the order you multiply in doesn't matter. So it's okay that this second fraction has the x minus 5 first instead of the x plus 4. The denominators are the same. So what we're going to do is we're going to create one big fraction. For your denominator, leave it in factored form. X minus 5, x plus 4. Your numerators, however, you do have to multiply your numerators out. So what that means is we're going to be going through FOIL on each of them. I'm going to just recopy them for now, just so we have a copy of them, just so it's written this way. All right, so we've got 2 rounds of FOIL to go through. Your denominator, you're just going to be, I'm going to be lazy, copy paste the whole way down. The only way that denominator is going to change is if in the end you have a common factor. Don't do anything with the denominator until the very last step. All right, so we're going through FOIL. First, outside, inside, last. So first, I'm going to go ahead and draw them all. Outside, inside, last. So we're going to get x squared minus 2x minus 5x, double negative, positive 10. Be very, very careful with the second one. If this is a minus sign, you need to use parentheses. Since it's a plus sign, it's not a big deal. But if this was a minus sign, immediately open a set of parentheses. All right, now we're doing FOIL again. First, outside, inside, last. So we're going to get x times x plus 4 times x plus 3 times x. And then 3 times 4. And I clearly did not make that bar long enough. All right, it's bothering me. That's not in the middle. All right, now we combine everything that's like terms. So if I'm looking at this, look at it very carefully. I have an x squared and an x squared. That is 2x squared. I have a negative 2x, a negative 5x. That's negative 7. Then I have a positive 4x. That's negative 3x. Plus 3x, that's 0x. So again, you're combining all of your like terms. So we got our x squareds together. That was 2x squared. Then we got a negative 2, negative 7, negative 3, 0. No x's. Then we go to our constants. We have a positive 10 plus 12. 10 plus 12 is 22. Again, leave the denominator alone. All right, final answer is in factored form. So again, denominator is already factored, so I'm going to go sideways because I'm out of room. Numerator, they have a 2 in common, so we're going to factor that 2 out, and that is x squared plus 11. And then the denominator stays x minus 5, x plus 4. There's that one. Oh, it's way up there. All right, next. Subtraction. Subtraction are the ones you need to be very, very careful with. So first things first, everything needs to get factored. 3x minus 1. Or sorry, not everything. Everything in the denominator needs to be factored. Denominator first is leading coefficient 1, so double bubble. We know it's x and x. Multiply to 3. Well, there is only one way to multiply to 3. Get to a positive 2. That means I need the bigger one positive and the smaller one negative. I have a minus sign. I have the x plus 4. X squared minus 9, difference of squares. X minus 3. X plus 3. All right, LCD. So goal is everything left to right that's different. So first thing we run into is x plus 3. X minus 1 is different. across. X minus 3 is different. And x plus 3 is a repeat. So don't list anything repeated. That's where things are going to get complicated if you use too many factors. All right. So what we're going to do is use our Formula 1. I'm going to be lazy. Copy, paste. So Formula 1 with what's missing from each denominator from that LCD we just wrote out. So if I look at the first denominator, I have the x plus 3. I have the x minus 1, but I am missing the x minus 3. So I need the x minus 3. So it has to go on the top and bottom. For the second fraction, we have the x minus 3. We have the x plus 3, but we are missing the x minus 1. All right. So now our denominators we can see are identical. So I'm going to go ahead, rather than just write each in a set of parentheses, I'm going to go ahead and get this written as a single fraction. So we have the lovely denominator, x plus 3, x minus 3, x plus 1. First numerator, each in its own bubble, x minus 3 times 3x minus 1. Sign in the middle, we need to be very, very careful because it is a minus sign. Minus sign, the x plus 4, x minus 1. All right, from here, multiply first. Again, playing the copy paste with the denominator. Denominator is just along for a ride. Copy, paste. Foil the first two. So first outside, inside, last. First, outside, inside, last. So 3x times x, 3x squared. Then we have a negative x. We have a negative 9x and a negative times negative, positive 3. For the second one, because that is a minus sign, I am going to put my minus sign, but then you need to open a set of parentheses for this multiplication because that minus sign belongs to everything that you're about to multiply out. So first, outside, inside, last. So I got my parentheses. First, x squared, outside, negative x, inside, 4x, last, negative 4. So before we combine like terms here, I need to get that negative distributed through. So if you wanted to go ahead and combine some at the front, you could. So I'm going to go ahead and paste my denominator again. And the negative x and the negative 9x, might as well go ahead and put those two together. It's one less thing to write down. Negative 10x plus 3. And then that negative needs to get distributed. So it's going to change the sign of the x squared. It's going to change the sign of the x, the sign of the 4x, and the sign of the negative 4. All the signs are going to become opposite because this negative gets distributed to all of them. Now we can combine. Oops, and I'm running out of room. So hopefully one last paste of our denominator. Hopefully we don't do it again. All right, 3x squared minus x squared, 2x squared. We have negative 10 plus 1, negative 9, minus 4, negative 13. And then we have 3 plus 4, 7. All right, you have to check for factoring. A lot of times it's not going to factor, but we need to double check to make sure it doesn't. So unfortunately, this leading coefficient's a 2, so we have to play the outside-inside game. So I'm going to copy. Let's see, does it tell us to? Yes, everything in factored form. So let's go this way for now. I don't think we're going to do that last one. I think this video is long enough for now. All right, so we're coming in, 14, and we're trying to multiply to 14, add to negative 13. So here's where you got to be very, very careful. I can get to 13 if I use 14 and 1, but I can only do that if one of them is negative. This is not negative. So we cannot factor this. It is not factorable. It's very close, but you've got to watch those signs to make sure they match up. They do not. So there is nothing else we can do. I think we did enough with that. Ooh, that was long. Scoochie, I'm gonna try to make it all fit on one page. All right. All right. For that last one, it's the same idea. I think you have enough examples for the video. I'll work through it and make sure it's completed on the notes. So I'm gonna stop the video here and do a separate video for the solving equations, just to break it up a little bit.